All right. The last thing we have to do is a mapping, and for a mapping, you need two ovals. I mean, I don't guess there's anything special about the ovals. They're just normally an oval. It doesn't have to be. I guess it could be a rectangle. It may not even have a border. It just may be a list of numbers. However, for mappings, the numbers usually are, this is where I'm looking. The numbers usually are written in numerical order, smallest to biggest, for both sets, smallest to biggest. We're not matching them up like we did over here at the table. If we were matching them up, it would just be a table inside of a circle. So it doesn't go the same way. We list them in numerical order from smallest to greatest, and we also do not read. So if we have the same value listed twice, in the same either X values or Y values, we don't list it twice. So for example, we don't have any X's that repeat. We've got a 4, a -2, a +2, and a 0. None of those repeat, so I'm going to put them in order. We've already done this once. Put them in order. -2, 0, +2, +4. So from the smallest to the biggest. Now we're going to do the same thing for the Y's. Put them in order from the smallest. The smallest here is -4. Now we have two -4s. We are not going to write -4 down twice. We're only going to write each number one time. We've already written -4 down. We don't write it down again. The next smallest number is -1. And I'm only looking at the Y values here. So -4, -1, and then the next smallest Y value is 3, or the biggest Y value, I guess, is 3. Okay, now to do a mapping, what we do is we draw arrows from each one of these X values to its matching Y value. So we see right here that -2 maps to -1. So we're going to draw an arrow from -2 to -1. Okay. We're going to see that 0 maps to -4. So we're going to draw an arrow from 0 and we're going to point it at -4. Ooh, and my line automatically changed to a straight line. That was nice. The next one is +2, and we're going to see that +2 maps to -4. So we're going to draw an arrow from +2, and we're going to point it at -4. So yes, -4 has two arrows pointing at it, and that's okay. And then we're going to see finally that this 4 right here maps to 3. So we're going to draw an arrow from 4 to 3. And that's how we do a mapping. So we've got a table. X's are usually in order. Y's have to match up with their X values. A mapping, X's in numerical order, Y's in numerical order, and then you show the matches with arrows. And coordinate plane, the first number tells you how far left or right to go. The second number tells you how far up or down to go. Domain, it's defined right here. The domain, it says, is the first number in each one of the ordered pairs. So it's this list of X values, or it's this list of X values, or you can see the first number see where it crosses, where we went on the X-axis to get to this point. Where did we go on the X-axis? We went to -2. Where were we on the X-axis? We were at 0. Where were we on the X-axis when we went down? We were at 2. Where were we on the X-axis when we went up? We were at 4. Okay, so the numbers that associate with the X-axis, those are called the domain, and this is how we would list them. Again, they're listed in numerical order. We put them the brackets in front because it is a set of numbers, and we do not repeat. Okay, so the range only has 3 because we had that -4 listed twice, and we don't list them twice. Here they're telling you that the variable in the value that is in the domain position, or that first number, that one's going to be called the independent variable. X is independent and Y is dependent. It'll make more sense when we are working with word problems to explain dependence and independence. Otherwise, it's just something that you memorize. These relations can be graphed without a scale on either axis and interpreted by analyzing the shape. So I'm not sure exactly what they mean with that. I mean, I know what scale is. This graph right here is scaled by 1 because each one of these little marks is marked by 1. What I'm not sure is why they're saying that you can graph without a scale, because I say you can't. You can't graph if you don't know, because unless it's marked, we don't know if each one of these little things are worth 1, or is it 5, 10, 15, 20, or is it 100, 200, 300, 400? You have to know what the scale is in order to be able to graph it. Okay, just like I said, for example 2, you really need a contextual situation in order to identify the independent and dependent variables. Here is an example. In warm climates, the average amount of electricity used rises as the daily average temperature increases and falls as the daily average temperature decreases. So here we're saying that the electricity is going, whether we use a lot or use a little, is going to depend on what the temperature is. That means that we would write that the amount of electricity depends on the temperature. That means the electricity, and I abbreviated that word, the electricity is dependent and temperature is independent. So that means if I were writing it as an ordered pair, okay, the temperature would go first. We have to know what the temperature is before we can say if we used more electricity or less electricity, a lot of electricity or little electricity. So electricity goes here. Okay, so we've got temperature and electricity. The temperature would be recorded on the x-axis and the amount of electricity would be recorded on the y-axis. Okay. So according to this graph right here, we have the graph represents the speed of the car as it travels to the grocery store. Time is independent, speed is dependent. So our speed depends on how long we've been going. So this one is always independent. And this one is dependent. And then describe what is happening in the graph. So here's what's happening. As we move along this x-axis, that means time is increasing. So the amount of time that we have been driving is increasing. So as the time is increasing, my speed is going from 0 up to whatever the value is right here. My speed is increasing. So here, and that's, we'll learn later that that's called, that to have, we would say that has a positive slope. But what's happening is as time increases, speed increases. Okay, so then it looks like the time is continuing to go. We're still counting time. We're still moving along the x-axis right here. But what happened to my speed? My speed kind of leveled out. It looks like as I took off, my speed increased as I sped along until I reached the speed limit. Then I stayed at that same speed until I over a short amount of time, I quickly decrease my speed all the way down to 0, so it looks like I stopped. Okay, so it took me just a little bit of time to stop. It took me a little bit more time to speed up. Then I drove along at the same speed, and then I came to a pretty quick stop. So that's, I would just write that out. My speed increased for the first bit of time. And then I would say, then my speed stayed, I'm going to use a math word here, stayed constant. I don't know why my pen's not picking up. C-O-N-S-T-A-N-T. My speed stayed constant for a bit of time. I don't know if this time is in minutes or seconds, so that's why I'm having to say just a bit of time. And then I stopped. Then I stopped quickly. Okay, because we see it didn't take that much time to stop. From about right here, from about right here to right here was the only amount of time that it took me to come to a complete stop. Okay, so that should be able to get you through working the worksheets.